Here we have a t-shirt. In this video, I'm going to teach you how the security tag lock mechanism that prevents people from removing this tag and stealing the shirts works. How does the mechanism in a security tag for clothes work? We have magnets underneath. We struggle a little bit, and there it goes. In this video, I'm going to show you how this mechanism works. Before we dive into the mechanism, I want to make sure we understand the big picture. What is a security tag? How does it work? And analyze the individual geometries of the different components. Once we understand that, then I can show you the mechanism in motion at the end and explain it step by step. So here we have our t-shirt. We've all gone to the store. We've seen these security tags. This face of the security tag will come in contact with this face of the t-shirt, and the part behind it here will come in contact with the back of the t-shirt. So the t-shirt is constrained. And if you try to pull on this tag, you won't be able to pull it back. There'll be some mechanism that will constrain this rod and will not allow you to move it backwards and therefore steal the t-shirt or for a good cause. So we want to know, this is quite amazing, I think. Something so small and purely mechanical can be so strong. So how does this work inside? Alright, so we're going to open up the security tag again. It is a struggle sometimes. There it goes. As you may have seen, I have magnets which match up with the bottom. I'm going to show you internally what's happening. Let's move this aside. We put the tape in place because we had opened this before, and the tape just holds it together a lot better. Okay, now let's take a look at the inside. Not a lot of parts, as you can see. We have the security device, which makes the alarms go off. So this is actually not part of the mechanism. It could be a whole video by itself on how that works, so we're not going to include it. Now we have the main housing and these parts here, and the mechanism essentially what's going on in here. So the pin is going to go through the hole, and then you can't take it out. But if you bring a magnet, I want you to capture the side view, then you can take it out, like magic, right? So it's nice and smooth once there's a magnet, but as soon as you remove the magnet, it's locked into place. So now we're going to open this little part right here to figure out exactly what's happening. And I can remove, okay? Now we're going to figure out what's going on in this mechanism. I also want you to see that there's a little spring in there. If you get closer, there's a spring you see in the bottom. Look what happens with that spring. I'll show you one more time, listen. You see that? Okay, let's pop this open. So fingers crossed. Let's pop this open. It looks like it's press fit. So when we open this, it looks like this. There's a spring. I should probably cut my nails before the video. We got this shuttle, and the shuttle has 3 balls in it. It's 3 ball bearings. The rest I'm going to show you in CAD because this mechanism is too small to show it to you in my hands. One thing to note is that these are all ferrous materials, meaning that they are attracted to magnets. The ball, the shell, and the outside, they're all ferrous materials. And that's important in the mechanism I'll show you next. Basically, now I'm going to peel the onion one layer at a time and show you the geometries of each individual component. So here we have our security tag by yours truly, Rafael Testai, and we pull the security tag back. We have a lid here. This lid can be popped off, but it's not part of the mechanism, so we'll get rid of it. Inside of it, we have the housing, which I showed you before, and these 2 mechanisms, which we're going to focus on. And actually, we only need to focus on one of them, so we can hide the one on the left. This one can go. and we have the lock mechanism on the right. I want to open this mechanism and show you the geometries, because once you familiarize yourself with the geometries, you'll have a much better understanding of what's happening. Let's make these bodies solid. All right, keep in mind this rubber outside, like the name implies, it's made of rubber. It's yellow that you saw in the previous video. And I'm just going to isolate these two bodies. So this one is called the metal bell. All right, let's do a cross section. And I want to show you something very important. These are the key geometries I wanted to show you. So this rubber outside has these channels that you'll see here, which perfectly fit the bell-shaped, metal bell shape that goes in there. And that's why it was so hard to get the bell shape out when I was trying to pop it off with the little screwdriver. I'm going to show you another view. So let's get rid of this body. And here are the channels. Once again, we got the top channel, the bottom channel, and right in the middle in blue is where, let's pull up the bell. Let's hide this body. That's exactly in that channel where this part of the bell will fit. That's very important. I will show you why in the mechanism later. Now I'm going to show you the shuttle that's on the inside, pink. We can make this transparent. The shuttle body, let's isolate it. And I want to make it solid so you can see all the geometries. So it's got these circular cutouts, and at the bottom, this circular cutout for the spring to be constrained. These walls will constrain the spring, which I will show you later on. But let's navigate it, look through it so you can see what it looks like. It's very small, so I'm very happy that we have CAD SOLIDWORKS to show you this. We're going to exit isolation mode. We have the spring, which I talked about before, which will come in contact with this bottom face. So I will go over more in detail momentarily. And lastly, we have these ball bearings. First, let's talk about the mechanism in the locked configuration when you can't remove the top lid, and what's happening one step at a time. Let's hide the housing. We can hide the lid. All right. This is a compression spring at the bottom that's coming in contact with the inner surface of the rubber bell here. And it wants to be expanded. It's a compression spring. In its expanded state, it will come in contact with this circular interface that I will highlight here. Right there. It wants to push it up. So it's pushing the shuttle in pink upwards. And that's causing the roof of the shuttle to come in contact with the roof of the bell-shaped, right here. Ball bearing, the metal bell. So that's coming in contact. So it's being hit and constrained in the roof because of the spring that wants to expand. Now, why do we even care about this? This is why. When you try to slide out the lid, the rod will come in contact with these three ball bearings. And it'll want to, since these faces are coming in contact, all three at the same time, it's going to make the balls want to rotate. But here's the catch. Here's where it all gets constrained. Because if that's the case, if they want to rotate, the ball bearings can't, because they will come in contact with the inside of the bell shape part. So let me open this part. Let me isolate it so you can see what I'm talking about. The ball bearings will come in contact at the very top with this face, and they will want to rotate, but they can't. And when they can't, that's going to create a normal force, contact force, on the wall, and the wall is going to push back on the rod with equal and opposite force. It's almost like a wedge, and the force gets amplified. So the more you want to pull on the tag, the more this ball is pushing on the inner wall, and the wall is pushing back. So that's why you can't remove the tag. I think it's pretty clever. By contrast, I'm going to show you what happens when you put the magnet underneath that allows you to remove the lid. So, step 1, you put the magnet underneath. Immediately as you do so, let's keep in mind the ferrous materials, which are the materials that are attracted to the magnetic field. So, it was the metal bell, the shuttle, they're in pink, and also the ball bearings. They all want to be pulled down towards the magnet that's hanging out down here. But here's the beauty of design that I showed you before. Keep in mind the rubber bell has these channels which will constrain the upside down metal bell. So the metal bell wants to go down and be attracted to a magnet, but it can't. It'll be locked in place, which means that only the shuttle, I'm going to hide this body, only the shuttle in pink can move down with the ball bearings. And when they move down, the spring will be compressed. Yes, it'll be compressed. It was expanded, it'll be compressed. That's what you saw when I zoomed in the video. You heard the little click. That's the spring being compressed. And what's happening now? The balls have a little bit of more room. Let me do a cross section. Have a little bit more room. These are cutouts to move slightly off to the right and slightly off to the left, and they will stop coming in contact with the rod. And that's, so you have to imagine that, okay? Just imagine the ball moves slightly off to the right, and imagine this ball moves slightly off to the left. Now, there's a hair of air in there, which allows you to pull this back. You could pull it in, pull it back as much as you want, as long as the magnet is down here. And that, ladies and gentlemen, is how this ingenious mechanism works. If you learned something today, if you enjoyed it, please like, comment below, and send me a message on LinkedIn as to which mechanism you would like for me to tear apart next and teach. Until next time. This video belongs to a playlist called the Mental Mechanism Library, in which we're going to study products all around us, figure out how they work internally, and save their mechanisms in our Mental Mechanism Library. This is going to make you a better mechanical design engineer.